So we've finished triggering the unit circles, big fat unit. We've been working on it all term. We're going to have a bit of a recap here, specifically of chapter 5 and 7, because they're the ones we did earlier. Chapter 6 should be relatively fresh, so I won't talk about that. But there are a few parts in here that I would like to talk about specifically. So what we'll do is we'll pull our notes book out and we're going to flick through it together. We'll talk about 5A, what we did in 5B, just to get the mind ticking over. So just in terms of revision for the test, I've made a bit of a list here of things you've got. So there's 2 tests. Both blank copies and solutions are attached to the assessment task on sector, so you can access them there. As well as the review sets. So we're doing chapter 5, 6 and 7. So there's 2 review sets in each. Now, not all of the questions are relevant, so I'm about to send an email. I've typed it all up, I just need to press send, of which questions are relevant. Okay? But even then, I'm advising you not to do all of them. I mean, you can if you want to, but you should, by this stage, be getting very deliberate about what you revise. Okay? So there's no point repeating a process over and over and over again if you know it off by heart. So you look at a question, you read it, comprehend it. Do I know how to answer this? Yep. Move on to the next one. If you're a little bit unsure, that's when you do it. Okay? So be very deliberate about how you're spending your time. Just in terms of like a maths test, I mean, we're probably pretty familiar with this, but when I'm marking a test, I'm not looking to see if you've got the right answer. I'm checking your process. I'm looking to see that you've understood the process. So that means you never rub anything out and you never cross it out unless you know it's wrong and you're putting something else there. Okay? Even if you know it's wrong but you don't know what else to write, just leave it. Maybe I can salvage some marks for you. My goal is not to see what you did wrong. My goal is to try and get marks for you and see what you did right. Okay? And then I've said there's worked solutions for these tests, and I can provide them for any of these questions you might have, let me know. But with worked solutions, how should we use them? So we shouldn't just have them open, we're doing the test, and then just copy what we see on the screen onto the paper. You're not going to learn anything doing that. Alright, so what I reckon you should do, you're doing the test, you got stuck, you're not sure where to go or how to do this question. Have a look at the worked solutions, read and comprehend, understand, follow it the whole way through. They did this, and they did this, and then that, and there's the answer, okay? Then cover it up, you know, Alt-Tab into Farmville or something else, and then try and repeat the process, try and replicate it, okay? See how you learn. So it's like in primary school, look, cover it up, write it, and then check it, okay? That's a good way to use worked solutions. Never have them open with the test and just copy. You're not doing anything. Okay, cool. So let's open up our books to 5A. We'll talk about the difference. We'll just go through. So in 5A, we learn about radians and degrees. So you will be required to perform conversions. And you will need to know when do I need to have my calculator set in radians and when do I need to have it set in degrees. Now basically, for chapters 5 and 7, it's going to be in radians exclusively. And then for chapter 6, questions from chapter 6, where we're solving angles in triangles and finding unknown sides, it's going to be in degrees. Okay? So that's a good way to think about it. The other way is to look at the problem. Okay? Anything that has pi in it, okay, anywhere you see pi, has to be in radians. Alright? If the function has pi in it, if the interval over which you're graphing it has pi in it, the calculator's got to be set into radians. Okay, so that's 5A. In 5B, we did arc length and sector length and area, sector area. And that was reasonably similar to stuff we're doing in chapter 6. It's like finding unknown lengths, and there's a bit of problem solving involved there. We will not dwell there long. In 5C, we introduced you to the unit circle. Okay, so we went through, we drew it, we said how we develop it, and filled it in, and then we just answered, we filled in tables. We look at the unit circle, what's the value of the y coordinate when the angle is 90 degrees, etc. We did that for sine, cos, and tan. Okay, then we're on to 5D.1. Now here we are going to do a question together. I've prepared it up here. Because you get probably, I think in the test there's maybe 6 to 8 marks based on some of these questions. So we'll go through one of these, we'll recap it. This is what it's going to say. It's going to say something like this. Cos theta is minus 4 on 7. we're restricted to a region, we're restricted to the second quadrant. Find all trig ratios, so that means find sine, find cos, find tan. Now from here, there's two processes we can do, and I don't care which one you do, you will get marks for doing either. The first process is that sine squared theta plus cos squared theta is 1. Okay, we're going to sub in cos theta, so we've got minus 4 on 7, so we're going to have sine squared theta plus minus 4 on 7 squared equals 1. And we're going to solve that for sine theta. Okay, so we'll rearrange, go ahead, rearrange all that, get sine theta by itself, and then we know tan is sine divided by cos. Okay, so that's the first process. The second process, or an alternative process you can perform, is where we draw that right-angled triangle. Okay, it's always got the same shape. Okay, we go ahead and label it. We've got our adjacent side, our opposite, and our hypotenuse. And we remember our trig ratios. So, Sokotoa. We've got cos is 4 on 7, or minus 4 on 7. Okay, so what that means is cos is A on H, isn't it? We've got that from here. Cos is A on H. So 4 corresponds with A and H corresponds with 7. Now we do not need to consider the negative at this stage. So when we're drawing it in the triangle, we're just going to ignore it. So we've got 4 and we've got 7. Let's go ahead and solve for O. Now to do O here, we're just going to use some Pythag. We can see we've got 4 squared plus O squared is 7 squared. Rearrange this. We've got O is the square root of 33. Okay, so that's just Pythag. We've rearranged it. And we should have, whenever we have square root, we have plus or minus. Okay, and now we're ready to answer the question. Based on this, we would have sine theta. Sine theta is O on top of H. We've solved for O here. It is plus or minus root 33 on H is 7. And tan theta is O on top of A. So that's going to be plus or minus root 33 on top of 4. Okay, so we're sort of 3 out of 4 marks of the way there, because then we need to localize our answer to the region that it's talking about. Just, are there any questions so far about what we've done? Okay, so if you perform this process, you would have found sine, and then you can use sine to find tan. If you perform this process here, it's a fair bit easier to just look, right, what's the value of sine, what's the value of tan? Okay, so then let's localize the region. If we're thinking about it, we're going from pi on 2 to pi, so we've got this region here, and in that region, the x values are negative, and the y values are positive. Okay, sine is y, so therefore sine has to be positive root 33 on 7. And tan, okay, think about this, tan is positive root 33 on 7. Remember, tan is sine divided by cos. So we have positive root 33 on 7 divided by negative 4 on 7. So we have a positive divided by a negative. Tan is going to be negative. And there's an easier way to think about that as well. So if we remember the unit circle, we can remember our acronym, all students talk cool. And so in this quadrant, we have all ratios are positive. In this quadrant, we have sine is positive, which means tan and cos are both negative in this second quadrant. Okay, so only sine is positive. Here, only tan is positive. And here, only cosine is positive. And so we've said that they're equal to this, and then we need a justification because, so we can do the invert the therefore sign, that means because, or you can write the word because, and then reference the region pi on 2 is less than p or less than pi. Now I've gone through that reasonably quickly, but hopefully that's sort of getting the wheels ticking over with what we did in 5D.1. Any questions about that process? Okay, let's jump to 5E.1. So 5D.2, what do we do there? I've ripped it out here. 5D2, we're using technology, applications of the unit circle, applications using technology, yep. And so then in 5E.1, we're back to using our unit circle, and it'll give you something like this, and it just wants you to evaluate it. So we look at the unit circle, we go, cos of pi on 6, that is root 3 on 2. And then we're going to multiply that by sine of pi on 3, that is root 3 on 2. You're just looking at your unit circle. What's the x value when the angle's pi on 6? What's the y value when the angle's pi on 3? Here they are. And then let's simplify that. That'll be 3 on 4. Now, if you had your calculator set in radians because we're putting an angle in pi on 6, and you put this in your calculator, okay, it's going to pop out with that. All right, you'd get 1 mark if you just wrote this. So remember, it's about demonstrating the process. So it's like use the unit circle. Well, that simplifies to be root 3 on 2. Sine of pi on 3 simplifies to root 3 on 2. And when we multiply them together, we get 3 on 4. Okay, so show the steps. All right, so that takes us to the end of chapter 5. Pause here, we'll leave it up. I've done lots of preparation for this class. Can we jump into chapter 7? Okay, and so in chapter 7, we're beginning to talk about the wave function. Now, I'm not going to talk so much about how it develops. That's sort of important conceptual stuff, but it's not something you can be tested on. What we'll talk about here is how we can find the equation of it and what sort of questions you could be asked here. So 7a talks about periodic phenomena. Something's periodic if it repeats itself in a horizontal direction. In 7b, point 1, point 2 and point 3, it introduces us to the sine function. So the general sine function is a sine b of x takes c plus d. And then in 7c we talk about the cosine function, which has the same effects. A, B, C, D have the same effects, just a slightly different shape. So you might be asked, for instance, to give you a question like this, say state the amplitude and the period. Okay, so with these values A, B, C and D, A is the amplitude, isn't it? That tells you the distance from the principal axis to a peak or trough. B tells you how many wavelengths there are in 2 pi. That's what the value of B means. Okay? That's what B means. But you can use B to tell you how long is it for 1 wavelength. Okay, so be aware of the difference between them. The number of B, whatever it is, tells you how many wavelengths there are in 2 pi. The period is the distance for 1 wavelength. How long is it for 1 whole peak and 1 whole trough? C, horizontal translation. D, vertical translation and your principal axis. So with the question here, you know, like the first one here, amplitude. What's the amplitude of this function? Y equals sine x. 1. Okay. How about the period? So I'm not saying what's the value of B, I'm saying what is the period? How long is it for 1 whole wavelength?
2 pi.
2 pi. So with the sine function, I'll write that period is equals 2 pi. The basic sine and cosine function both have a period of 2 pi. Okay, 1 wavelength in 2 pi units. Here, the amplitude is 2, and the period is 2 pi on top of B. Okay, in this circumstance, B is 5. So here we're going to have 2 pi on top of 5. You could think about this one and go, the period is 2 pi on top of B, and B is 1. 2 pi on top of 1 is 2 pi. Okay, so there'll be questions like that. Find the amplitude, find the period. There'll be graphing questions. So let's say you had to graph this function. You can put it straight in your calculator. Okay. Then we get into, there's a couple of graphs and it says find the equation of these graphs. And they'll give you an axis, they'll give you some information, but you need to find the equation of it. And you need to determine, is it sine or is it cos? So, I'll just go up here quickly. So sine starts at the principal axis and has a peak and a trough. Cos starts at a peak. Okay, cos starts at a peak and finishes at a peak. That's 1 wavelength of cos, peak to peak. Or you can think of a sine wave as a whole peak and then a whole trough. Okay. All right, so over here, let's decide. We're going to find the values of A, B, and D. Now there won't be C because there can be a little bit of ambiguity when you need to find the value of C, horizontal translation. So we're just sort of ignoring those. They just get a little bit clunky. We're just focusing on A, B, and D. So here you might go, there's not really enough information. So obviously that's touching at 0, so that point's 0. And the principal axis, it may not be illustrated for you, but it is always halfway between the peak and the trough. So if it's between 0 and -10, halfway will be -5. All right, so that means our value of D is -5. The amplitude is the distance from the principal axis to a peak, or principal axis to a trough. And the value of B is how many wavelengths are there in 2 pi? Well, we have one whole wavelength there. We're going from a peak to another peak. That's one whole wavelength there, and another whole wavelength there. We've got 2 whole wavelengths in 2 pi, so our value of B is 2. Okay, now it wouldn't be enough to just write A, B, D. We need to state the function, and so that means we need to determine, is it sine or cos? Well, it's starting at a peak. Okay, so if it starts at a peak, it's cos, so that means it's going to be 5 cos 2x, take 5. Okay, we're just putting the numbers in the formula. Okay, any questions? Excellent. So let's move on to this one then. Let's identify the values of A, B, and D. This is a sine wave. Hopefully we can see that. Starts here. We've got a whole peak, a whole trough. So let's go for A, B, D. So D, principal axis, is +3. The amplitude is the distance from the principal axis to a peak. So that'll be 4. And then B. We don't have 2 pi there, so we can't really see exactly how many wavelengths there are in 2 pi. How many wavelengths are there in 2 pi? Don't know. 2 pi is not on my scale here. All right. But we do know that one wavelength, or one period, is 2 pi on B. So that means, I'll write it up here, 2 pi on B is equal to, what's the distance here for one wavelength? We're told it. One wavelength is 4 pi on 3. Okay, so we're going to rearrange this to get B by itself. B equals 2 pi divided by 4 pi on 3. Okay, you can put that in your calculator. You can perform it using an A on B on C on D. If we evaluate this, we'll get 3 on 2. All right, so 3 on 2 or 1.5. What that means is there's 1.5 wavelengths in 2 pi. Okay, any questions about that there? That was a little bit tricky. I'll just explain that again. We know the formula, so that's the difference between these 2 points, isn't it? Okay. Over here we can see that there are 2 wavelengths in 2 pi. That means B is 2. Over here we don't know how many wavelengths there are in 2 pi, but we do know one wavelength has a length of 4 pi on 3. So that means one wavelength, 2 pi on B, equals 4 pi on 3. We rearrange to get B by itself. That's what we want. So the equation of this function, it's a sine function. Our value of A is 4, B is 2, and D is +3. Now one way you can check to see if you've got it right, only if you've got time, would be to graph that and make sure it matches up with what is displayed on the Cartesian plane. Okay, so that's 7B and C. 7D is about the tangent function. Then in 7E, there's 3 parts to it. 7E.1 talks about solving trig equations using a graph provided. 7E.2 talks about it using technology. So maybe I'll just mention that quickly. So that might be where you have cos x equals 0.521. Find x for 0's less than x less than 3 pi, or something like that. Okay, so you restrict the domain, you graph this function, and then you're doing a g-solve. X calc, I want to know the x values that make cos x equals 0.521. Okay, then in 7E.3 we're doing it algebraically. Okay, so we've got this trig equation, and we need to find the solutions between 0 and 3 pi. So the way we solve this is we get cos x by itself. So we'll do that in a few steps. Okay. We look at our unit circle and we go, when is the cos value? Cos is the x. Okay, when is it +1/2? So it's going to be here and here, isn't it? That's +1/2. And those angles, we're going to get x equals pi on 3 and 5 pi on 3. Okay, well, I'm getting those from the unit circle. And then, we're not quite finished, because let's consider our domain. It says from 0 to 3 pi. Now, if we went around once, that would be 0 to 2 pi. But we need to go around again to here, don't we? That's going to be 3 pi, which means this solution repeats itself. Now, our first solution is pi on 3, so if it's repeating itself, it means we're adding 2 pi to it. So they're going to be our 3 solutions, okay? And you can simplify that, either using your calculator or fraction operations. Okay, that would be full marks. Now, there is one question in the test, we'll prepare you for this now, that says find all solutions. Find all solutions. So here, when it says to find all solutions, what that means is you're going to find the solutions for one revolution. Okay? So let's say this same problem again, we've got cos x is half. These are the 2 angles that make that statement true. But then we want to include every possible solution in every possible rotation. So the correct way we're going to provide this notation is plus k2 pi, where k is z. Okay, let's explain that. This means k is an integer, right? And what it means is k could be positive 1,000, which means you're going around the unit circle 1,000 times, or it could be negative 1,000,005, so you're going back the other way 1,000,005 times. But it doesn't matter what k is going to be some whole number. It's going to guarantee you solve every possible solution. Okay? So you can write it plus k2 pi or plus n2 pi. It doesn't matter, some letter, some program. Alex, you okay? Yep. Where k is an integer or n is an integer, it means it's a whole number. Okay. So that's 7E3. 7F talks about problem solving, so there's a nice problem there. I'll just talk about that one quickly. You are given a domain and a range over which to graph it, okay? And so let's say you've got the graph of it, something like this, and it will say something like indicate on the graph when, now this is not the context, I'm not going to give much away, but it'll say indicate on the graph where the population is less than 5,000, okay? So that might be, oh, here's 5,000, so the population is less than 5,000, and you might shade that region, okay? It's less than 5,000 here, or you might indicate it somehow with arrows. How you're going to get marks for a part like that. So that's 7F. We're using our calculator a lot here. Make sure you put the function in properly. Make sure you have the domain range set as it dictates in the question. And then in G, G is about those formulas where we're expanding and simplifying using those double angle identities. Okay, so there's 2 or 3 marks for questions like that. Excellent. So chapter 6 should be relatively fresh, but there's an overview of chapter 5 and 7. Hopefully it's reasonably refreshing. Yeah, so we can get in, we can do some of our own revision. I'll come around and see what we're up to, see if we've got any big questions.